Inserting variability to project activities. Part 1. Observe for activity 1 on row 3 that besides the most likely estimate on cell B3 for $2,000, the expert's opinion deems a variation with respect to a minimum point, 5% on cell C3, and to a maximum point, 30% on cell D3. Using an at-risk distribution function, we could use 3 parameter points, a minimum, a most likely or mode value, and a maximum in order to recognize the varying nature of this activity. Notice that the expert's opinion generates an asymmetric distribution. In other words, the distance between the minimum and the most likely central value only spreads apart 5% from it, whereas the distance between the mode and the maximum value spreads apart 30 percentage points. In other words, the minimum would be $1,900, the mode of 2,000 minus 5%, while the maximum would be of $2,600, the mode of 2,000 plus 30%. At-risk allows the usage of all syntactically correct Excel clauses. Therefore, it is possible to construct at-risk distribution functions with formulas that, for example, make reference to other cells. If number 1, there is no data, and number 2, no other distribution is appropriate, and number 3, a reasonable guess can be made for a minimum and maximum, then the PERT distribution is a reasonable choice. 17. On cell E3, write the following formula. Equals risk PERT, open parenthesis, B3 times, open parenthesis, 1 minus C3, close parenthesis, comma, B3, comma, B3 times, open parenthesis, 1 plus D3, close to parenthesis. Notice that this function carries along 3 parameters required by the PERT distribution. The first parameter represents the minimum value, which in this case is calculated as the mode minus 5%. The second parameter is the mode or most likely value itself. It is the value contained on cell B3. The third parameter is the maximum, which is the mode plus 30%. Each one of these parameters is separated as any other function in Excel by separating commas. 18. Once the cell has been written, edit it with the define distribution at risk icon. This will open the distribution chart as follows. On the right-hand side of this chart, a table containing several descriptive statistics is shown. Observe that the mean or average is slightly different at 2083.33, which is different from the mode, which was the parameter that we inserted on the function at its $2,000 level. This is due to the fact that the distribution is skewed or asymmetric. On a symmetric distribution, the mode, the mean or average, and the median or 50th percentile all share the same value. That is the property of symmetry, that in the center, all 3 measurements of centeredness are the same. The fact that they're relatively different stems from the fact that symmetry towards the right-hand tail is 30% away with respect to the mode, whereas the left-hand tail is only 5% away. The mean on a PERT distribution is calculated as a weighted average. To calculate the mean, the PERT adds up the minimum plus the maximum plus 4 times the most likely value, and then divides this whole sum by 6. In other words, it weighs 4 more times the central point than the 2 extreme points of the min and the max in order to calculate its average, mean, or expected value. Another very popular distribution is the triangular, which also uses for its construction the 3 same parameters required by a PERT. At-risk allows comparing distributions. 19. Click on the Add Overlay button while this PERT distribution chart is open and select from the palette a triangular distribution. Since this distribution shares the same 3 parameters with the PERT, there is no need to change them for the triangular. As a matter of fact, the triangular inherits the parameters for comparison purposes. 20. By dragging the right delimiter the vertical line on top of the chart, above the $2,400 mark value on the x-axis, observe how much probability, area under the curve, lies beyond according to each one of the two distributions that share the same three parameters. Observe that the triangular distribution assigns 9.5% probability of an outcome larger than or equal to $2,400. On the other hand, the PERT distribution only assigns 1% probability at this mark. In other words, if the project manager considers that spending over $2,400 would already be an extreme situation that demands action, a critical point, then the triangular distribution would impose such an outcome on close to 1 out of 10 possible outcomes, whereas the PERT distribution would only assign such an outcome once every 100 possibilities. In other words, the triangular weighs as much as 9.5 times the tail of the distribution at points beyond $2,400. The triangular distribution has these desirable characteristics. 1, it is relatively easy to specify, and 2, even if it overestimates the extremes, if not significantly overestimated, it can then be considered as a conservative distribution. The more biased distribution, the triangular one, will tend to have tails that are fatter than the PERT. The analyst should then decide which distribution best describes the behavior of the tail. Therefore, as we have seen, the triangular distribution has these deficiencies. 1, in cases where there's a very small possibility of an extreme event, the triangular will tend to overestimate the probability of an extreme result in this case. 2, it assumes linearity of the probability density function. We tend to prefer the shape of a PERT distribution, which assumes the predominance of the results occurring in the most probable range, and then the tails are rounded. In other words, a triangular distribution creates a mathematical discontinuity at its peak or mode, which seldom occurs in nature, something that the PERT avoids. We will insist on using the original PERT distribution on top of these risks. The overlaid triangular distribution will only remain there for comparison purposes.